Hello everyone. We are now going to talk about some of the prerequisites for the next lab. So lab number 2 is up. It is the C++ bug hunt. You can get to it from the schedule here, or you can go to the menu on the left and click lab 2 C++ bug hunt. And so what I've done is I've given you 4 programs that each have a problem with them. And your job is to find the problem, to fix it, and then to describe to me what you did. Okay. Now, I'm going to be sort of testing your knowledge of pointers and showing you where pointers seem to go wrong. I've actually put in here some mistakes that I've made myself in the past, very common mistakes. So I'm hoping having this lab at this point in the course will buffer you, so to speak, against future mistakes that you could make with using pointers. Okay. So the first thing I'll do is I will clone this lab, and so let me go ahead and I'll clone that lab. Let me just do that here. Sorry, let me show you my terminal. Okay, so I'm going to clone the lab. Let me cd into that directory. And let me also go ahead and open this up in Visual Studio Code. Okay, so I've opened up the first bug here. Here's the code. Let me go, I'm going to show my terminal here, but of course you could launch the terminal in Visual Studio Code. Let me compile the first program. So called bug1. So I'll do it like this. And I'll run the program. And there's a segmentation fault. All right. Now, segmentation faults are a little bit difficult to track down without using a debugger. Okay. So you may have seen a debugger before. But this is a program that you can run your program inside of that allows you to freeze the execution of the program and look at the variables at various points. And it will actually automatically freeze the program and show you what's up if there's a segmentation fault or another memory problem. Okay. So we're going to be using a debugger in this class called lldb. And I'm just going to show you some of the basics of this. If you want to know more, go back to the schedule and look at this lldb cheat sheet. And there's also a different tutorial here. But the cheat sheet's probably all you need. So I'm just going to show you a couple really basic commands to get you started and really to get you enough to do what's in this lab. Okay, so to run lldb on a particular program, I'm going to write lldb and then whatever command I'd use to invoke the program. Okay, so there we go. All right, so to run the program, you just type R for run. So it's going to run it, and it tells me, okay, it got a segmentation fault. That's what this means here. And then it shows me all this stuff, which is not particularly helpful at this point because this is what's known as assembly code. This is what the machine code actually is. This is what the computer's running. Okay, but we want to see. It would be nice if it could tell us like a line number in our original C++ code before it was converted into machine code. So in order to do that, I have to recompile this. I have to go back up and I have to add an option -G. Okay. So in addition to saying, okay, I want to save it to a file called bug1, I also have to add this -G, which adds a symbol table, is what it's called. So it's going to add information to tell us how to convert from the machine code back to C++ code. I mean, we can still run it ourselves, and we won't really notice much. But actually, if we go to run it in lldb, we'll get a completely different result now that we've included the -G. Okay. So when I run this code again, now it's actually showing me a line number in my original C++ code. So see how that matches up with that? And this is much more helpful. Okay, so it tells us, hey, where you got a segmentation fault was on this line. All right. So probably something with this array access. Are we accessing something that's out of bounds? Or maybe is this array a null pointer? I don't know. But the really cool thing about the debugger is when the execution freezes, you can actually examine some information about the variables that are there. So I can print out the variables. For example, if I type p space I, that'll print out what I is holding right now. So I is holding the number 1136, which is a bit suspicious because the array that I passed along to this method only has 10 elements. So I have no business going to index 1136 in my array. And remember, this is one of the dangers of C++. Unlike Java, arrays are not objects and they don't have out-of-bounds checks. So I can go out of bounds in an array and it'll either pull out some garbage numbers or it'll throw a segmentation fault. So in this case, it threw a segmentation fault. Just to show you other things you can print, if I printed out X, well, this is an array. And so it's a memory address. So it's showing me a very large number, which is the memory address of the array. I can print out individual elements in the array. And so on and so forth. So that's a nice little command. Whenever I'm done, I can press Q to quit. And I will go ahead and do that. All right, so that was cool. I know what line this is happening. But maybe I want to do a little more. Maybe I want to not wait until this thing has gone through 1,000 times, but maybe look at it every iteration of the loop to see what's happening. Okay. So if I go back and run lldb again, but this time I type B space 7. And this is just the simplest way to do that. These are very fancy ways to do this, but this is setting what's known as a breakpoint. Okay, so the code is going to stop on line 7 no matter what. Even if it's not going to crash, it'll stop there as soon as it gets there. All right, so I've set a breakpoint. And now when I type R, it's stopped. It says the reason is because you reached a breakpoint. And now when I go to print the index I see I get a very different number. And that's because it broke as soon as I got there. So I is equal to 0. This is the first iteration through the loop. And I'm already going to break and stop. Okay. Now to continue, we can step. And that's S for short. So I'll go to the next line. Okay, that's S. Go to the next line. Now it's back up at the loop. Go to the next line. And just to show you, so that went through one iteration of the loop. Now I is 1. I'll go again. I'll go again. Now I'm down here. I'm in the second iteration of the loop. Okay, so you can step through just like this. Keep stepping, keep stepping, keep stepping. And print information just like that. Okay? And of course, you can set multiple breakpoints. And this is all very nice. Okay. Now, if you're like me, I'll be completely honest here. You'll generally maybe you'll just use the debugger to help you find segmentation faults. I still get a lot of mileage out of just throwing in different print statements. Some people discourage this because it can really clutter your code. Some people are really into just using the debugger if they're totally elite or whatever. But print statements are fine too. But I'd be remiss if I didn't show you this additional tool. And again, if you get into this enough, you definitely want to look at the cheat sheet and see all the other things that you can do. You can actually even change variables as the code is running in a way that wouldn't necessarily have been changed in the code itself. So anyway, that's the intro to the debugger. And so I have just a couple quick questions for you on Canvas about it. And so hopefully you'll be able to spend all day on Wednesday actually hunting for these bugs. Okay, see you then.